Hey guys, today we're going to talk about special right triangles. We're going to do Unit 2, Lesson 3. Before we get started with our first type of special right triangles, I do want to talk about a rule that we haven't discussed yet when we're dealing with radicals. So if you turn your notes to the very back, I have this little spot at the bottom for some extra notes. Okay, so this is what we're going to add here. We cannot leave a radical in the denominator of a fraction. We have to simplify it. So my example here is 6 square roots of 2 divided by square root of 3. So here's how we handle this. We can multiply this by 1, the number 1, and it won't change its value, okay? Now, just remember that anything divided by itself equals 1, and so what I will do here is multiply by the square root of 3 divided by the square root of 3. This equals 1. Its value is 1. So I'm really not going to be changing the value, just making sure that there are no radicals in the denominator. So square root of 3 times the square root of 3 is pretty much the square root of 3 squared. And we know that a square and a square root simplify and cancel each other out. So I just have 3 on the bottom. All right. Next, I need to multiply across the top. So I have a 6 times 1, which is 6. You multiply the numbers on the outside of the radical, and then you can multiply the two radicals. So the square root of 2 times the square root of 3 is the square root of 6. 6 square roots of 6, because 2 times 3 is 6. And then your last move, if possible, is we can simplify the 6 divided by 3. 6 divided by 3 is 2 over 1. So I now have 2 square roots of 6, which is equal to the same value as this was. Okay? It's equal to the same value. Okay. And so if you want to check this in a calculator, you can. Notice what I started out with was 6 square roots of 2, all that divided by 3. In my calculator, I just had to put the 6 square roots of 2 in parentheses before dividing by the square root of 3. And then I typed in 2 square roots of 6, and they come out to the same decimal value. So I didn't change the value of what I have. I just changed how it looks. Okay? So we will use that today during our lesson. Now let's go back over to the first page. And I'll zoom back in a little bit. So we're going to start talking about special right triangles. And the first one that we're going to talk about is the 45, 45, 90 triangle. Okay? There is a special relationship here that always exists. Notice that 2 of the angles are the same measure. So what that's going to mean is that the 2 legs are the same measure. So they will be, generically, we're just going to say they're x, okay? And then if you were to square these and add them together using the Pythagorean theorem, you would have 2x squared equals the c squared. Well, in order to get the c squared by itself, you'd have to square root it. And so you would end up with x squared would just become x. And the 2, when you square root the 2, wouldn't be able to simplify. And so this is how we would write that, x square roots of 2. Okay? All right, so let's go ahead and take a look at our first example with a 45-45 triangle. So once I see that this angle is 45, this angle is 90, this must also be 45, okay? 45, 45, 90. So if this leg equals 25, this leg and this leg are the same measure. So the value of y is 25. It's going to be the same. And so now what does this x value equal? Well, it's going to be 25 square roots of 2. And that's it. Okay, we're just using we're just going to use the rules up here. Okay, so 25 square roots of 2. Let's take a look at a second example. This time they gave me the hypotenuse. Okay, my hypotenuse is equal to 19. So let's think about this. This would normally be x, and x square roots of 2, okay? So if I say 19 equals the x square roots of 2, let's divide both sides by the square root of 2 so that I can get the x by itself. 19 square roots of 2 equals x. Well, I cannot leave the square root of 2 on the bottom. So I'm going to multiply this by square root of 2 over the square root of 2. And so on top, I will have 19 square roots of 2. And on bottom, the square root of 2 times the square root of 2 is just 2. And if you want to really see how that works out, okay, the square root of 2 times the square root of 2, anything multiplied by itself is itself. So it's 2. We use the exponent 2. And then remember that the square and the square root cancel each other out. Okay, so that's how I'm just left with the 2. Now, if that is what the x value is, well, this is a 45, 45, 90. So the x and the y are the same value. So 19 square roots of 2 divided by 2. And that's it. So you know how to start with a leg and figure out the hypotenuse, which is really easy. And then you can also start with the hypotenuse and figure out the legs, which is a little more tricky. Okay. All right. Let's talk about our second type of special 90-degree triangle, which is a 30, 60, 90 relationship. Okay. So 30, 60, 90 right here. Now the shortest leg is going to be opposite the smallest angle. Okay. The shorter leg, we're going to call this x. So that's our x. Okay. The longer, the longer leg opposite the 60-degree angle is going to be x square roots of 3. So x square roots of 3. And then our hypotenuse will be equal to 2x. Alrighty. So let's take a look at our first example of this. So in example number 3, they give me this 60-degree angle here, okay? That 60-degree angle, what's opposite of it is x, which means that this is the longer leg. And so this down here, this 5 is going to be the shorter leg. All right, and then obviously this y is the hypotenuse. Okay, so where am I? So the short leg is x. So in this case, the short leg is 5. To figure out the longer leg, I'd have x square roots of 3. So I'd have 5 square roots of 3. And then to figure out the hypotenuse, if x equals 5, the hypotenuse is 2 times x, or 2 times 5. So that is 10. Okay, let's take a look at our second example of this. I'm going to make this a little, I'll scooch this. Okay, so find the value of each variable. So I see the 30-degree angle here, which means that this x is the short side. And so this 9 square roots of 3 is going to be the long side. Okay, so if you take a look at here, the longer leg would be x square roots of 3. So if I'm looking at this, that means that the x in this case is 9. Okay, and now to find my y, which is the hypotenuse, I would do 2 times 9, which is 18. And that's it. I'm all done. Okay. So if you only have a 30, 60, 90, it's easy to focus on these rules. And if you only have a 45, 45, 90, it's easy to focus on what these rules are. But let's go ahead and put it all together. This is where it really starts getting tricky. Okay. So I'm going to flip over to the back side. So what I see here, what I see here is a 45, 45, 90 triangle. And I also see a 30, 60, 90 triangle. Okay. They've given me the angles, and then they've given me one of the sides. So this is a 9. I'm starting here. Now this is on the leg of the 30, 60, 90 triangle, and it's opposite the 30, which means that this is the short leg. Okay, so this is x. Now let's figure out what the hypotenuse would be. The hypotenuse for 30, 60, 90 is 2x, which would be 2 times 9, which is 18. So I found a z. Z is 18. Okay. Now I'm ready to find the longer leg. The longer leg. The longer leg is x square roots of 3. So that's going to be 9 square roots of 3. Okay. They didn't ask me to identify that side length, but I needed to find this side length in order to then find these over here. Okay. So now I'm moving into my 45, 45, 90 triangle. So I need to remember the relationships here. Okay. These two legs are the same measure, and this hypotenuse would be these measures times the square root of 2. So let's do a little bit of work for this. I have x square roots of 2. That is the hypotenuse of a 45, 45, 90 triangle. And it currently equals this 9 square roots of 3. Well, I need to get that x by itself to figure out the length of my legs. So divide both sides by the square root of 2. Okay, and then we're left with this, 9 square roots of 3 divided by the square root of 2. And we cannot leave it this way. So we're going to multiply by square root of 2 over the square root of 2, which is going to equal 9 square roots of 6 divided by 2. And then 9 divided by 2 does not simplify nicely, so I just have to leave it that way. Okay, so for both x and y, they're the same. So I have 9 square roots of 6 divided by 2. Okay, very good. So we are mixing these together now. Example 6. Example 6 starts out with giving me some information about a 30, 60, 90 triangle. Okay. I know that since this is 60, that's going to be the long side. So this must be the 30-degree angle, which makes this the short side. Okay, so the short side of my triangle is 7 square roots of 3. I need to figure out the hypotenuse. So the hypotenuse, I'm looking at my little cheat sheet, right? The hypotenuse equals 2x. So 2 times 7 square roots of 3 equals 14 square roots of 3, and that's the value of x. Okay. I need to figure out what is the longer side, only because it's going to help me with the other triangle here. So let's figure out the longer side. The longer side is x, which is this right here, square roots of 3. So 7 square roots of 3 times the square root of 3 is what's happening here. And when I do that, I end up with square root of 3 times the square root of 3 is just, let's see, 7 times 3, which is 21. So I have 21 for this. 7 square roots of 3 times the square root of 3 should be 21. Okay. And now there's nowhere to write that answer, so it wasn't anything that they had asked me for. But now I can use this information to find y and z, okay? So now I am in this triangle here. This is opposite the 30, which means that this is the short leg, okay? This is opposite the right angle, so this is the hypotenuse. The hypotenuse is going to be equal to 2 times this value, which is 42. And then the short side is going to be this value times the square root of 3. Times the square root of 3. So I end up with 21 square roots of 3. Okay. 21 times the square root of 3. And I have found all the sides. Let's take a look at an EOC example. And this is a hot mess right here. Okay, I have 3 different right triangles. This is a 60, 30, 90. This is a 45, 45, 90. And this is another 30, 60, 90. They said if AB equals 8 square roots of 3, find AE. So AB is right here, and they told me that this is 8 square roots of 3, and they want me to find this side right here. Okay, so that's all the information that they're giving me other than these angles. So let me switch to blue. So everything in black is the original problem. I'm going to now show my work in blue, okay? So I am starting with this 30, 60, 90 triangle. So this 60, what's across from that is the 8 square roots of 3. So that is the long side, which means that this 8 is the x. So this side is equal to 8. Now I need to figure out the hypotenuse. Well, the hypotenuse is 2 times this value. So 16. All right, so I figured out the 3 sides of the first triangle. Now let's move over to the 45, 45, 90. This is the 45-degree angle, so is this, which means that this side and this side are the same measure, okay? And I need to find this side right here, opposite it. Well, this is going to be, the hypotenuse is x square roots of 2, so 16 square roots of 2 is that side length right there. And now I'm back to a 30, 60, 90-degree triangle. So the 30-degree angle is here. So this is the small side. This will be the hypotenuse. And so what I have is the longer side that I know of, okay? Okay, so here's what I'm going to do. I know that my longer side is 16 square roots of 2. 16 square roots of 2. But I would really like to try to figure out what the x value is, because that is going to represent the smaller side, okay? So to figure out the smaller side, let's solve this. Remember, the longer leg was x square roots of 3. X square roots of 3. So if these are equal to one another, let's divide this by the square root of 3 so we can figure out what the x is. So we are dividing by the square root of 3. And so we are going to have to multiply by the square root of 3 to get that out of the denominator. And so what I will end up with is, let's see, 16 square roots of 6 divided by 3. Okay, divided by 3. So this is what the small side equals, because I solved it for just what is x. So this is x. 16 square roots of 6 over 3. Now I'm ready to find the hypotenuse. The hypotenuse is 2 times x. 2 times x. So that means I need to take this and multiply it by 2. Okay, so 16 square roots of 6 divided by 3. I'm going to multiply that by 2. So I get 32 square roots of 6 divided by 3. And that is the hypotenuse, which is completely and utterly crazy, but that's our solution. Okay, let's look at our very last example. And this is like a word problem application. Okay, So the garden club at Heritage High wants to build a flower garden near the outdoor seating at the back of a school. So far, all that information was really irrelevant. Okay. The design is a square. It's a square, if I can draw a square, with diagonal walkways. So I'm picturing it being like this. Okay. The length of each side of the garden is 50 feet. How long are the walkways? So they want to know, how long is this whole side right here? And because it's a square, each diagonal would be the same measure, okay? So here's what happened. Here's a 90-degree angle right here. And this is cut exactly equal, which means this is a 45, 45, 90 triangle. Okay, so if this is 50, that means this side is also 50. And so how do I figure out in a 45, 45 triangle what the diagonal is? Well, I take the 50 and I multiply it by the square root of 2. And so that's my solution. Each walkway is 50 square roots of 2. Okay, and that's it. All right, guys, so that is our lesson for today. It will take some practice. Let me pop this back up here. I definitely suggest that you keep your cheat sheet in front of you. These are what I'm constantly using to solve for, to set it equal to what the longer leg is, and then figure out the x value, okay? Or whichever one of these that I need to use. So keep those handy. There is a practice assignment posted for you. Until next time.